Good morning, everybody. This is a live severe weather briefing on the potential for an outbreak today across central and eastern Iowa into central and northern Illinois as well. But there are some forecast failure scenarios that are becoming apparent so far this morning. There is some earlier convection that is developing already in northeastern Oklahoma. That's going to race off to the northeast. That could potentially limit the warm front progression northward through central Illinois. It could lead to some messier modes along that warm front. Also, it could delay, or it could cause those storms to initiate before the arrival of the more favorable kinematics just ahead of that surface low. But I began with this image right here. This is the latest HRRR forecast for 21Z, so that's 4 o'clock. And this latest model run shows an arc of supercells moving through central into eastern Iowa at this time, with the greatest helicity across northern Iowa, but still more than sufficient helicity across eastern Iowa through the middle to later part of the afternoon for even a strong tornado threat. And then after that, that fast-moving arc of supercells crosses the Mississippi River into northwestern Illinois by this time. But as often is the case with these setups, you have to decide between playing a warm front that is lifting north through central Illinois that may or may not be impeded by some earlier convection that's developing, or do you target the more favorable kinematics that are being indicated by the latest HRRR runs for central and eastern Iowa, or do you hang right near the Mississippi River and wait for these fast-moving storms to approach while there are tornadoes ongoing over portions of southeastern Iowa? Many times, the HRRR, it used to be the rock back in the day. I'm not saying the HRRR used to be the rock, but back in the day, the short fuse model known as the rock would often show supercells and more favorable thermodynamics and kinematics happening in Iowa, and then way off to the east of that wave along the lifting warm front. That's where the main tornado event happens across central and northern Illinois. And I certainly know that storm chasers that are from this area, meteorologists from this area, know how these setups work out, where usually those supercells and tornadoes happen well off to the east along that lifting warm front. But then there are those cases where it actually does happen in Iowa, and this right here shows a very favorable arc ahead of that surface low, big low-level jet backed out ahead of it. You're talking 200-300 plus 0 to 1 kilometer helicity out here, but this environment is going to march east with time, and even if the tornado threat is just a little bit delayed by earlier convection across Illinois, it is likely going to arrive there anyway. So before we really break in and dig into the forecast, I first want to show you the outlook. The SPC has maintained a moderate risk in the outlook across northwestern Illinois into far southeastern Iowa. They also have that lobe of the enhanced bending back into northern Iowa to account for the latest HRRR trends for a slightly slower system and those more favorable kinematics being just a little bit further west. And with that earlier convection developing in northeastern Oklahoma heading right in the direction of central Illinois, I could certainly see that earlier convection happening before the favorable kinematics arrive, and that certainly could be a failure scenario in terms of the forecast. Here are the tornado probabilities. The hatch area that you can see, the hatch area outlined here, that is for significant tornadoes. This is the 15% in red. That's where the greatest coverage of those strong tornadoes is expected to happen. But boy, the latest models are showing the warm front lifting a little bit slower across central Illinois, impeded by that convection that's lifting up from northeastern Oklahoma right now. That could slow the progression of that warm front and not allow it to reach the favorable kinematics that will be in place across northwestern Illinois. The latest models are actually trending toward central and southeastern Iowa, showing a more favorable tornado event. But that will again spread in to Illinois by evening with those fast-moving storm motions and a very progressive system. So no matter what, there's likely to be a strong tornado threat, even if the northward progression of that warm front is slowed down just a little bit by that earlier convection. And here is mesoanalysis that shows that convection that's developing right now. It's across southeastern Kansas, Oklahoma. You can see there's a lot of intense jet dynamics. Look at all the hydrometeors fanning out like that. You got the convection initiating there in central Oklahoma, some elevated convection as well, but there's a lot of strong winds aloft transporting the tops of those storms well off to the northeast. But this complex here is going to move rapidly off to the northeast along this boundary, and I do think that those storms could impede with the central to northwestern Illinois mode of this event. It does look like, though, that this MCS is going to slide east of central and eastern Iowa. So central and eastern Iowa will likely be largely untainted by that MCS that's lifting off to the northeast. But the latest runs of the HRRR are definitely picking up on this, and I want to show you how this might impact the forecast. So again, as I mentioned, that's at 4 o'clock. Let's zoom back out here and see where the position of the surface low is according to the HRRR. See if it's in agreement with the wrap. Let's also see if it has this morning convection developing. The HRRR does have this convection, and the latest HRRR, at least, this is the 10Z run, does have that convection from central Oklahoma into eastern Kansas. It's maybe even underdoing that convection just a little bit. Let's see where the surface low is located on this 10Z run. This is the forecast for 12Z. It's got a 997 surface low there. And the wrap also has the surface low there in central Kansas at about 997. Also has the precip initialized there. That's happening right now. So it seems like the HRRR has a good handle on the position of the surface low and the convection that's evolving right now in southeastern Kansas. And let's see how that evolves with time. Going out to 14Z, it lifts that convection already up into northern Missouri there. This is elevated convection by 14Z. But boy, does it lift out fast, according to this model. This is by 16Z, 10 o'clock in the morning. Has convection across, this is elevated convection across eastern Iowa into western Illinois there. Progression of the surface low by this time, by 14Z, is almost up to Omaha already and deepening rapidly to 994 millibars. This elevated convection is in eastern Iowa into west central Illinois by 10 o'clock. That's 3 hours, so it lifts from southeastern Kansas up to northeastern Missouri and southeastern Iowa in 3 hours. That's an aggressive time frame, I would say. But this is a deepening surface low, a progressive system. Everything's going to happen faster with such strong winds aloft. And so the latest HRRR then lifts this convection into northeastern Iowa and northwestern Illinois by 17Z, and by midday it lifts it out. It does have some storms trying to develop along the lifting warm front in central Illinois, and the elevated mix layer spreading from southwest to northeast across the southern plains through Iowa. And this elevated mix layer is going to clear things out as it punches from the southern plains into Iowa ahead of that surface low. That's dry air at the mid-levels of the atmosphere. And here is that low-level jet axis at 18Z at midday. It's in central Missouri up into far southern Iowa there. And this is the axis that we want to track as it moves off to the east. That's midday. This is at 2 p.m. And the core of that, the nose of that low-level jet axis is punching into southeastern Iowa by about 2 p.m. The core of that axis is still back in Missouri. The stronger 850 flow in excess of 35 to 40 knots is beginning to overspread western Illinois by this time, by about 2 to 3 p.m. And look at the stronger flow beginning to move into the target area, the moderate risk area here by about 4 p.m. 40 to 50 knot low-level jet you're talking about here into southeastern Iowa. And now we're going to look at where that convection develops. So this convection here is likely going to limit the lift of that warm front. There could be an isolated tornado threat with any of this convection all the way down into eastern Arkansas, the Missouri boot heel, central and southern Illinois, all the way up to that warm front. And then you've got this arc of supercells developing in eastern Iowa. They actually develop in central Iowa, and by 4 p.m. it is still well west of the Mississippi River. This is the arc of supercells that are likely going to be producing tornadoes across eastern Iowa here. These will likely also have an isolated tornado threat. But boy, is this going to be a tough forecast. You're definitely going to have to decide between going to the west of the Mississippi River, where you have more organized convection, fast-moving supercells, likely producing tornadoes. These are also going to be supercells, but there is a hint that this is a slightly messier mode. This is out ahead of the main low-level jet axis, as you can see. But man, a lot of times these happen anyway, even east of the main low-level jet core, near the lifting warm front across central and northern Illinois. A lot of times well ahead of the main favorable kinematics, or the more favorable wind fields to the west. That's where you end up getting those tornadoes. Sometimes they'll develop a little bit later in the day. But by 4 or 5 p.m., that low-level jet is going nuts in east central Iowa into northwestern Illinois. That arc of supercells is still progressing. Starting to close in on the Mississippi River by this time, by about 5 p.m. According to this version of the HRRR, it could be much faster. And again, these predecessor supercells out here could easily have an isolated tornado threat. The best low-level jet, though, is in eastern Iowa. In fact, northeastern Iowa even. I can show you the wind shear according to this. The HRRR, very strong 0 to 1 kilometer storm relative helicity across east central Iowa into northwestern Illinois. Let me get rid of my noggin so we can break this down a little bit further. Let's look at a forecast sounding near Davenport, Iowa by about 5 p.m. And this is, of course, a PDS tornado type hodograph. Look at all of this storm relative helicity within that hodograph curve. You've got a lot of easterlies too. That's why you have a lot of that hodograph and this northwestern quadrant up here. That's because the surface wind is due southeasterly, the 1 kilometer wind due southerly at about 50 knots. And then you've got very strong upper level winds to contribute to those 50 knot storm motions, southwest to northeast. Look at this elevated mix layer we were talking about that's spreading from the southern plains across Iowa. A lot of dry air coming in between 700 and 500 millibars. A ton of turning as well there in the atmosphere. A lot of strong flow aloft, as mentioned. But this is a textbook outbreak type of a hodograph here. They're going to have fast moving storms, a lot of helicity. The critical angle is 70 degrees. That's even close to 90, but it is a little bit shallow in the 0 to 1 kilometer layer. But there's so much helicity, such a strong low-level jet that it's going to more than compensate for any limitations provided by that shallow critical angle, or even this subtle veer-back veer above where it even matters, above about 2 to 3 kilometers. And then we can also look into northeastern Iowa. This is to the north of the warm front, but still a favorable hodograph for tornadoes. But the thermodynamics north of the warm front, of course, are not going to get it done up there. You can see that warm front right in that helicity line, or just to the north of it, the helicity blows up where you get more of those east-northeasterly winds. But this is the plume right here from southeast to northwest, where that strong tornado threat is going to be realized. This is the 0 to 1 kilometer energy helicity index. It's a combination of CAPE and that low-level shear, and it really shows that environment prime for strong tornadoes in east central Iowa into west central Illinois here, Galesburg area up toward Davenport, a little bit to the west of Davenport. So definitely a big outbreak right in this bullseye. This is where the strong tornadoes are going to happen. This environment that precedes it along the warm front could get an isolated tornado or two, but it's just not as prime as this environment up here across eastern Iowa into west central Illinois. That's the area that I'm really watching. That's the core of the low-level jet, 3, 4, 5 p.m. The timing of this still could change between now and when it evolves by late afternoon. It could be a little bit quicker, could be slower. One thing that we picked up on yesterday morning was that the HRRR appeared to be slowing down the system just a little bit, which is not surprising. And that's bringing it back into eastern Iowa, bringing eastern Iowa back into play. Now let's look at a surface map. We should have started with the surface map because they're real obs, but I often will start with the RAP analysis. It's kind of a lazy way of plotting that surface map. But you can certainly see the warm front, and it looks like it meanders into far southern Illinois as well. Very juicy air. You've got upper 60s dew points funneling north. Here is that surface low. Temperatures to the north of the warm front, quite stable. Upper 40s, near lower 50s right there. But this is going to evolve rapidly. You've got some snow in northeastern Colorado, snow across portions of the Nebraska Panhandle on the wraparound or the backside of this system. This was quite a progressive system, or else it would have dumped quite a bit of snow across Denver and the foothills, but it quickly moved out. There was a lot of dry air, a lot of banding, a lot of dry air in between those bands. But that low intensified in eastern Colorado, and now as the bottom is about to drop out as it lifts northeast from central Kansas toward the Omaha area, all of Iowa is in the 40s right now. The warm temperatures are, the warm front is now through St. Louis, it appears. The pseudo-warm front temperatures near 70 in the upper 60s. You've got fog to the north of the warm front. That's what those horizontal lines mean right there. But this is going to be a rapidly developing mid-latitude cyclone. Lots of moisture streaming northward. And it is definitely going to be happening. Let's look at the RAP analysis. And you can see the warm front right now. But boy, look at this convection that's coming out of northeastern Oklahoma into southwestern Missouri. That's going to cause some problems, I think, with the lifting of this warm front. But the elevated mix layer is coming in behind it. It's coming in behind it, and it's going to arrive in the target area by early to mid-afternoon. Let's look at the 6-hour forecast, and you can see that happen. Look at that cape just explode into southern Iowa there. But the RAP is depicting a slightly slower solution as well. It has a renegade storm developing on the lifting warm front in central Illinois there, but you can see a little bit of anticyclonic curvature at the surface. But then you start getting that cyclonic curvature closer to the surface low back into southern Iowa. So that's 4 hours. This is 6 hours, so this is by noon. So by noon, there is a ton of instability. The warm front is up near the I-80 corridor, according to the RAP. So most of the models seem to be leaning toward a eastern Iowa play, but you also don't want to get all the way into eastern Iowa and mess it up. You can see the 3 to 400, 0 to 1 kilometer, or actually effective storm relative velocities near that warm front. That's at noon, and that's going to be pushing east rapidly toward the Mississippi River by about 3 to 4 o'clock. Normally, you don't want to go west of the Mississippi River due to the lack of river crossings, and you might get caught in the Iowa side, and then the outbreak will unfold off to your east in western Illinois. But the models are definitely slowing down just a bit. This is at noon, south central Iowa. It has that effective helicity max. Look at the relative minimum effect helicities too with that warm front with those renegades off to the east. But the RAP definitely weakens that. Oh, there it goes. So the RAP also has that convection lifting rapidly to the north as that low-level jet gets more backed. It lifts through eastern Iowa and western Illinois. So that precip is going to blast through, and then the atmosphere recovers, and then the outbreak begins in central Iowa, then eastern Iowa, and then northwestern Illinois there. Let's go back really quick to the SBC outlook. So there is a text in this outlook that mentions that this region could be upgraded to a high risk. You may even want to extend that risk a little bit into southeastern Iowa to account for the slowing down of this system. But really, my plan is to wait very close to those river crossings, wait for those storms to arrive on the Illinois side. But this is going to be a very fast-moving system, probably 4, 5, 6 supercells, all producing potentially strong tornadoes, moving at over 50 miles an hour. So very fast storm motions. You want to stay tuned to those watches and warnings and realize that these storms are moving fast, and you may need to start your safety plan even before the warning arrives. You can track those watches and warnings through the Radar Omega app. And of course, local media, National Weather Service weather radar or weather radio. Make sure your batteries are charged up and you're always getting those warnings. Information saves lives, especially timely information. Another thing that saves lives are having those severe weather safety plans dialed in and well rehearsed. I know that the pandemic is happening and you want to practice social distancing. If you do have symptoms, or even if you don't, and if you have some masks and gloves available, it is likely prudent to include that in your severe weather safety kit. Wear those to any community shelters. Call your community shelters in advance as well to see if they have any restrictions regarding the pandemic. But this is definitely about as dangerous as it gets here across central northern Illinois into eastern Iowa with a very dynamic system ejecting. And just stay safe. It's going to be a long day, and then there are some severe weather events ahead as well. Early next week, looks like Dixie Alley gets active once again. So it's that time of year, as we're just starting to get to April, when severe weather season really ramps up. So stay tuned, everybody. Thank you for joining me for this severe weather briefing. Still looks like a significant tornado day on the way. There are a couple forecast failure scenarios, however, but with such a dynamic system, usually the favorable dynamics, the favorable thermodynamics usually will outweigh any of those little adjustments that need to be made to the forecast. For example, with that convection right now that's lifting rapidly to the northeast into Missouri, and eventually it'll lift out of the warm sector. So have a good Saturday, everybody. Stay tuned to the weather and dominate the storm.